Welcome everyone to our new web series, Architecting Data Strategies with YugabyteDB. We're thrilled you can join us for our first episode of this new on-demand video series. These discussions are specifically designed for all the IT architects out there who influence how your organizations handle data and respond to the changing needs at the data and database layer. Now, throughout this series, I'll be joined by a number of solution architects and industry experts that have spent their careers helping organizations like you implement databases and solve tough problems. This is our chance to tap into all that experience and help you understand approaches and technologies that you can leverage to tackle real world problems or scenarios you face. From building a modern system of record for your business, to implementing testing for resiliency, to connecting your data layers together with streaming and event data. We've got a list of topics, but today we're here to take our first topic on, and that's talking about building a modern system of record. So let's meet our primary speaker today. I'm thrilled to be joined by Amey, the VP of Solution Architects at Yugabyte. Welcome, Amey.
Thanks, Michael. Thanks for having me here today. Nice to meet you, everyone. It's my pleasure to be here today with Michael and give you real-world insights into some of the modern system of record design and actually give you a use case on how we have done this for retail industry as well. Again, just by the introductions, my name is Amey Banarse. I lead the global field engineering team here at Yugabyte. Been with Yugabyte for about 4 years now. And mainly what our teams basically do is they are customer-facing architects. So we take your use case and we will help you modernize your entire database architecture and your footprint with YugabyteDB, which is a scalable, resilient, developer-friendly cloud-native database. And throughout the series, you're going to hear from most of our team members on how exactly we have architected certain mission-critical use cases. And more importantly, what are the business value add-ons or how did we help the customers' revenue growth as well? So Michael, thanks again for having me.
Awesome. So yeah, it's a pleasure to have you, Amey. And again, this is just a brief introduction of myself. So I lead the product marketing efforts here at Yugabyte. I've spent the last 15 years at various parts of the IT stack, from networking to storage to virtualization, cloud, and now databases. So slowly moving up that stack. All right, let's get to the topic at hand here, Amey. We're here to talk about systems of record databases. So let's spend the first couple minutes here just level setting on what is a system of record.
Absolutely, Michael. I would say as we work with Fortune 500 industries here at Yugabyte, we come across pretty much every single use case, which is a system of record, right? But if you have to really define it, it's actually the core custodian of mission critical data for that use case. That is, as in when you're designing your applications and you want to hold the true state, the true system of record or system of truth for that data set, then that's the system. It's a database system typically, originally run by more legacy systems in the industry, but that's the system that would hold the true state of the data and classify it as system of record. And between you and I, Michael, and all of our viewers here, we touch a system of record every day in life as we work with web applications. So imagine if you're logging to your own banking portal and you see your accounts, checking accounts, credit card accounts, saving accounts, or let's say if you use Zelle as a way to pay your peers or friends, then that's essentially touching every single aspect of a system of record for a financial system as well. The same thing when you log into your insurance provider or your healthcare systems, you go view your healthcare records, that's stored in a core system of record. So in all, anything which stores mission critical information will classify as system of record. It does come with a few characteristics that we'll go over on the slide itself.
Makes perfect sense. So let's talk through what are those core elements of the system of record and those characteristics that are important to keep in mind as we're thinking through what we maybe built in the past, but more importantly, looking ahead as to how we modernize these systems.
Absolutely, Michael. So let's do one thing. Let's take one use case as an example, right? So let's say you and I usually would shop online on any retailer's platform, or I sometimes like to go walk in Whole Foods or Trader Joe's, right? When you go and see those products and you go to the checkout and would actually go and buy those products, they actually touch the system of records on various cases, right? So if you only focus on that product catalog or an inventory system, let's say you put that in the center as a system of record. Now you have data coming into product catalog through various different sources, and you have a customer profile information. When you're buying a product, your loyalty points get applied, you get a cash back in certain cases. You have data which is coming from core system of record for a retail industry, which typically happens to be a mainframe, believe it or not. It's 2023 and mainframes are still pretty hot in the market when it comes to system of record, or it's coming from certain marketing data as well. So that's the information which gets fed in. And now this information is supplied to downstream systems like analytical and data warehouse systems. And it's also supplied to user-facing microservices. So typically these microservices are stateless, but they would go to your user-facing applications or a partner or an inventory database itself, or even your websites and promo and apps itself. So think of it as essentially a core system which is holding all the inventory and product catalog information for that use case. Now, if you have to really define the key characteristics that this center of our architecture should have, I think the first and foremost, I would say the accuracy and consistency of data. That is, you want to make sure that any information put in there is accurate because it now is a system of record truly for all the downstream systems and your end user facing applications itself. And at no point in time, it should have a downtime. It's hard to do that, but there are systems and replication and sharding strategies out there which will actually help you define this criteria and provide you a highly available system as well. And that's one of the things that Yugabyte does with all of our use cases. We do help provide highly available, resilient data store for all of our use cases as well. And the next one would be, let's say there is actually a downtime because some natural disaster or a power outage. Then how do you recover gracefully and seamlessly from the last known transaction standpoint? So that itself, in Yugabyte, we defined it as point-in-time recovery. So essentially going and recovering from the last known snapshot seamlessly and minimizing the downtime to your end applications or your end users. It is a very true critical piece of the system of record. And in this case, a product catalog would be. And that also helps you define really solid RPO and RTO guarantees to your end customers. So we at Yugabyte, we strive for zero RPO for every single use case because we take care of it with strongly consistent data sharding and replication of data itself. And we minimize as much as possible the RTO window that you would have from any outages, basically. And this is something we're going to deep dive into in our conversation later today.
Right. Yeah, I was going to say, I know we're going to get into those details here in a little bit. But before we get into those, though, I mean, we've listed these requirements for a system of record. We've established that basically any industry with critical data uses some system of record. But that also means that this isn't a new problem. And we must have been doing this for years. I mean, it's what fueled IT giants like Oracle. But we know IT doesn't stand still. We've seen this rapid change in the IT stack lately from cloud adoption at the infrastructure layer, app modernization, microservices at the top. And we're starting to see finally that data layer in the middle grow through its own phase of rapid change. What's driving this change? Why should we be thinking about these database changes and system of record changes now?
Yeah, absolutely. And I think we found a perfect use case for today, right? Today happens to be a pretty big shopping spree, thanks to the fact that Amazon Prime Day is going on right now, in the US at least, right? And when you talk about global product catalog, this is something exciting because each one of us gets to experience this every year, maybe during Christmas break or Thanksgiving or Black Fridays, right? And it's essential to understand what makes it so unique. Like, why is the customer experience the most important thing? How do these systems scale? How are these systems designed to handle failure? So those are the things we're going to look into. Now, from the global retailer perspective, I think it starts with top priorities in the retail industry, right? Number one, as I mentioned, is enhancing the end user experience. So that is, whether it's a normal shopping day or a peak day like Thanksgiving and Black Fridays and Christmas days, you want to ensure that end customer gets a seamless experience. That is, typically, we like to have a one-click checkout for your favorite items that you've already put in your wish list. It's not a hard thing to ask for, but you know what? There are about 90% retailers out there in the US which don't do this today. And it's extremely hard for them to replace their existing incumbent mainframe systems and provide this modernization to the end customer. And that itself gets them to revenue losses by customers' loyalty shifting to a new provider itself. The second one, in this day and age, making sure that the efficiency and your cost margins are pretty solid. That is, ensuring that you build systems which require low maintenance or very good automation behind the scenes so that you can scale up, scale down massively without any overhead for months. And that itself translates into, once you've designed a really good system, you would also build a trust and availability around it, like ensuring that customers' data is securely and safely stored, with compliance to your geographic distribution or domicile restrictions, and making sure it's available at every single point whenever your customers want to log in and look through their orders, their wish list, or even go buy new products end of the day. And lastly, providing that cloud native experience to your end users by sleek applications and making sure that we are able to go and buy products quickly. You have to be able to collect your loyalty points quickly or use it at some other travel provider or things like that. So when we started working with our global retailer, we actually came down through like a list of expectations from them. Mainly it was about scale and outages. That is, will be able to scale the system on Black Fridays and Thanksgiving, and will be resilient to the outages, because give or take, every 51 days, there is a public cloud outage. So how do you design against those is the most important thing for our teams. And we have done this successfully as well. I think net global retailers like this one do not want to get locked into a specific platform or a specific cloud provider. So they like the flexibility and adaptability to new cloud platforms and making sure that they can tap into their data centers or burst into cloud providers whenever required to provide that smooth, seamless experience to the end user. We should talk about like why now is a time to basically help modernize some of these mission critical applications for the end users, right? And this comes with a little bit of history, and I'll paint a quick 30-second picture for you. Most of the retailers go through this journey. I mean, a decade or two ago, they would have started with a monolithic RDBMS like Oracle in most cases, or a mainframe. Perfectly fine system for back in the day, when you have a packaged application sitting right next to Oracle and ability to serve data without any issues. The problem starts when you give up on vertical scaling after a point. And the only way you could essentially grow the systems was vertically scale Oracle. And there is a point after which you couldn't vertically scale. And that's where very cleverly data architects started to think that we can actually create manual sharding. So think of it as keeping a metadata state table somewhere outside, so that based on the application and what data it wants to essentially go and serve to the end user, it would look up the shard number and hit the right database and serve that data. Which itself introduces complexity into your end architecture, because now you're kind of dependent on your system being live, which is a core system of record, the metadata system being live. And if at all one of the shard gets very high or very hot, or essentially goes out of bounds from storage perspective, then you have to reshard over and over again, and becomes a very complex system to manage. And if you have an outage, it takes forever to figure out how to reconcile the data and at what point the outage happened as well. So this itself led to the advent of NoSQL databases in the industry. So about, I would say 12, 13 years ago, when the NoSQL system started becoming very popular, they solved for exactly the sharding and scale problem that the old school legacy system couldn't handle. But it introduced yet another issue, which is lack of SQL semantics from the application standpoint. That is, every single application that was written for decades now had to completely change to adapt to NoSQL databases standpoint. And this lasted, they had a good run, especially this global retailer had a good run with a NoSQL system like Cassandra for about 5 years, after which they started incurring a lot more issues to their downstream systems, because since the data wasn't kept in a relational format, led them to have a lot of overhead in again masking and regenerating the data models for the end systems, and kept adding to the complexities. And that's where they stumbled upon Yugabyte through their core research. And when we met with them, they were trying out different distributed systems out there. Like Cassandra was one option. They tried Cosmos DB. They tried a few other cloud hosted solutions back in the day. But the core issue still remained was, can we provide global consistency of data in a multi-region setting, let's say at least in the United States, with very low latency and high throughput of data, and ensuring that it can withstand cloud failures itself. So pretty massive challenge in front of us as a team, but we worked with them. And today I can say that we have successfully done 3 large Thanksgiving holidays for them, and at a very large scale. Actually, at one point, we had to 8x the size of the cluster to meet the demand from their end customers.
Nice. And you articulate that challenge really well. So now let's jump back and start getting back into the architecture here and talk through understanding these challenges, understanding, again, there's new expectations from these organizations. So what does it take to build that at scale? And what have you seen be successful in these deployments that we started to do today?
Absolutely, Michael. So let's do this. Let's take our viewers through a journey of how actually a global product catalog is getting built, right? And again, folks, you can actually apply these practices to any other industry. You can do this for financial ledger. You can do it for a healthcare system of record. The characteristics still apply, but today we're going to focus mainly on like the data modeling and the data pipeline for a global product catalog. So first question I typically get on this slide is, what does a catalog identification service really do, right? So think of it this way. It basically stores in a system of record format the core copy or core global ID for your product. That is, let's say if you buy a Nike t-shirt, let's say your favorite soccer player jersey you're going to buy, and let's say it has 5 different colors and 10 different sizes, then each of that combination now becomes a global product ID, and that's stored in this global product catalog. And then let's say you are in the market to buy an iPad, and when you go to this global retailer, you see a global retailer itself selling that iPad with 10 other options coming from different marketplace vendor. Then this system acts as a way to uniquely represent that single product across the entire ecosystem. That is, this system takes care of grouping different global uniquely identifiable products and still show various options when you're buying online as well. So that as a user, you can get to pick which offers the best quality of product versus which offers best cashback and things like that. So that's how important this identification service is for the ecosystem for a global retailer, right? And now, as you can imagine, with everything that we talked about before, that this system, it's extremely important for the system to ensure that the data consistency and correctness is guaranteed for every single transaction that the global retailer is serving. And more importantly, it should scale seamlessly. It should be able to handle peak holiday season with the same amount of performance and SLA guarantees that the end customers expect. And that's what makes it very interesting. It's actually a really good problem at scale, but at the same time, you want the scale up and scale down operations to go seamlessly without any downtime, or you want version upgrades to go or any hardware changes to go without incurring any downtime to end customers. And that's what we do here with our teams at Yugabyte. We ensure that there is zero downtime live migration of the system, and we're able to scale up and scale down for any holiday season. Now, Michael, if you ask me, let's talk about technical attributes for some of these things, right? So for such a use case, typically it's extremely read heavy. So you can expect about 90% reads throughout the day, 10% writes, like 10% changes to your catalog that happen throughout the day, right? Consistency of the system, as I had explained before, it's extremely important for asset compliance to be there for every single transaction in this case, because you have end customers buying your products, you have downstream systems taking your read information and write information as well, right? And mainly it has to work in a geo-distributed multi-region deployment to begin with. In terms of performance, everyone likes everything fast nowadays. So it has to be low latency system. And for this use case, at least for the last 3 years, our numbers look something like this. Our P99 for reads is about 3 to 5 milliseconds, given the fact that we have heavily optimized the system for reads, even though it sits in a geo-distributed deployment. And then for writes, since it's a multi-region, multi-data center deployment in the continental United States, we have to incur for the cross-country latency. So that's why writes tend to happen between 50 to 75 milliseconds. But let's say P99 of that is close to 75 milliseconds right now. And then in terms of the bulk loading, this is where us as in Yugabyte have helped tremendously. That is, we were able to take the data from their legacy incumbent systems, help them transform it with cloud native data pipelines, so combination of Spark, Kafka, and Akka streams. And now every night, the data flows through different disparate systems, get updated into Yugabyte through a bulk load pipeline. And then during the day, minor catalog refreshes happen, maybe 5% of the times or so. Great. Now, in terms of the deployment topology, this is where things get very interesting. And it may come as a surprise to some of the viewers here. But yes, you can actually take YugabyteDB and deploy it in a strongly consistent format across multiple data centers. The industry likes to call itself this topology as a stretch cluster. That means your single cluster is kind of stretching across different geographies. So in this case, for a specific use case, we deployed a 36 node cluster in which you have 12 nodes in West, 12 in Central, and 12 in East. And this forms one single cluster of Yugabyte. And now when we started doing the traffic analysis for our customer, we realized that most of their calls were coming through mid-waste load balancers. That is, based on the traffic pattern, about 80-85% of the traffic was actually reaching out to the US Central load balancer. So what we did was, Yugabyte allows you to have a very heavy read optimized system. So you can essentially, through optimization called as preferred leaders, where you put all the leaders of the shards for Yugabyte in one single region, we are able to guarantee them the 3 to 5 millisecond SLA on reads, even though Yugabyte is split. Yugabyte is deployed across the multi data center cluster in this case. So that's what makes it really unique from a global product catalog standpoint. And then when you scale up and scale down the system, there's no human intervention required to repurpose the apps and load balancers. Our drivers and the application endpoints are cluster and topology aware, so you can just seamlessly scale or scale up, scale down without any issues. And more importantly, since we were fortunate enough actually to be born in the cloud native era, we de facto support reactive architectures. That is, this customer has tapped into digital modernization effort of creating reactive asynchronous architectures and stateless microservices. That means they can scale up hundreds of instances of any stateless microservice within minutes. And thanks to that, they're now able to connect to Yugabyte and leverage that reactive stateless nature of the applications itself, because Yugabyte provides that out of the box as well. Now, in terms of the data pipeline, as I'd mentioned before, most of the bulk loading of the data comes from Kafka. So you can see different Kafka topics have been created. The cleansing of data, everything happens through Spark and Kafka combination. And once the data is cleansed, it comes to Yugabyte, lands into Yugabyte as a system of record. And then throughout the day, you have reactive Spring microservices, which are consuming data from Yugabyte and serving it to the end applications itself. There are about hundreds of microservices which do that with Yugabyte today. And I really like their choice of Spring here. Spring is an enterprise Java framework which allows you to deploy really solid microservices. Even the top folks like Netflix use them heavily. We work really well with Spring as an Yugabyte standpoint. We have Spring Data Yugabyte, which helps you seamlessly build any microservices application in minutes at times. Now let's tap into some of the data modeling here, right? It's very important to understand that when you migrate from a legacy architecture and a legacy database into Yugabyte, we don't force you to change your data models at all. Actually, you can lift and shift the application, and that's the true benefit you get out of Yugabyte, because end of the day, Yugabyte is a distributed SQL system. We offer you two different APIs, a Postgres compatible API and a Cassandra compatible API, right? Now, in this case, before Yugabyte, this customer used to store global product catalog data in 50 odd tables, because their existing system, which was Apache Cassandra in their digital transformation case, that wouldn't allow you to do any sort of consistency and any sort of relational guarantees anyways. So that put a huge limitation for them to create their own indexing strategies and sharding strategies. So with Yugabyte, you can tap into globally consistent secondary indexes. That is, you can define a table, you can create an index on top of any of the columns or a set of columns that you would want. And now you can efficiently look through the data with one single hop without having to go back and forth and reading from primary table and secondary table and creating indexes yourselves. So it's a huge efficiency gain in terms of a developer's time in architecting the application and in ensuring that all the work is actually done by the database as opposed to on the application side itself. So the performance gains for such a thing are extremely high from this global retailer's efficiency standpoint. So this is one other example I wanted to give you. That is, let's say, given the data model, if I'm looking for a certain product, let's say that was my ASIN, which is the globally unique ID, then I can quickly go and look for any categories like books and have a limit and an offset and it's basically an extremely fast read operation for us. Now, the second thing that we wanted to highlight here is that you can actually do global ACID transactions at scale. And this is where we were very different from their incumbent application architecture and their database architectures. That is, they were not able to do global transactions at scale, which put a huge limitation on the amount of orders that they can provide, and then they have to reconcile the data every now and then. With Yugabyte, you can do a multi-row or a multi-shard operation seamlessly. So that means you can do something like begin end transaction in a single block, and it will be ACID compliant transaction itself. So just again, giving you a sample of like what all you can do. As I mentioned, begin transaction, let's say you update certain set of tables, you insert into certain other tables, and you end transaction. This operation basically happens in one single transaction block, or will roll back if something doesn't work out. But this kind of an operation was impossible for them to do in their previous incumbent platform. And they had to do these transactions on the application side, which meant very high complexity in their application, a lot more manual maintenance, and not really being stateless applications to begin with. The third thing I wanted to mention is that it's extremely easy to do UI and pagination from a retail perspective. That is, let's say you define simple tables like product, there's a category like music. I can do a simple query saying that, I want to limit 10 and offset by 20. Extremely easy for you to do pagination without having to read data and do client-side filtering. And that's the reason this retailer's website is extremely fast, because they tap into these core things from Yugabyte perspective. And the last one I'll leave you with is natively storing a JSON-B data. So think of it as Yugabyte essentially taps into the document data model heavily. Our core storage engine is called DocumentDB. And we take JSON-B data type and we store it natively in our core storage system. So that means you can essentially have a JSON-B model and in your data model, and you can start storing that data, and you can create indexes on top of JSON-B attributes itself. So we give you extreme flexibility. We don't have to stick to a data model across, you don't have to define all the columns upfront. You can use JSON to have flexible schemas, and helps you with your different merchants onboarding and things like that as well. So this is something that customer team tapped into a lot and helped them minimize any changes to their existing application, plus simplify their application architecture as well. So Michael, I hope this has helped you tremendously gain insights into the use case. As I mentioned, this has been live for more than 3 years as a use case. I can assure you all of our viewers here have used the system. That means you have used Yugabyte in your lives already.
Yeah, that's great, Amey, and it's great to see the flexibility the system provides. And you've hit on a lot of features there that have, again, we've highlighted the product catalog as a use case, but that apply to just a broader set of core system of record databases. But one thing we haven't hit on yet that I want to make sure we hit on before the end of the time here is we've talked about the advantages and the features of these advanced architectures. We've looked at the topology, some of that architecture, but we haven't hit too much on availability. So in the closing time we have here, let's talk through how does that architecture help us deliver that high availability that's required for a system of record, and maybe give I know you have a great example of something where this has been put to use, so you can talk the listeners through that as well.
Absolutely, Michael. And you know what, as you said, we actually got battle tested for our availability and resilience guarantees in a natural disaster kind of a fashion. So folks, as a story here, in January of 2021, there was a snowstorm in Texas. For the viewers who are surprised, yes, there are snowstorms in Texas nowadays. And what happened was this customer of ours ended up losing their public cloud data center completely for 4 days in this snowstorm outage, because the entire state of Texas had lost power, and even the backup generators and anything couldn't help them recover the data. I mean, at least the data center in this case, right? So going back to our topology, the way we had deployed Yugabyte was essentially 36 nodes across 3 different data centers, strongly consistent. So you end up losing 9 nodes without any heads up, without any warnings, right? Now, Yugabyte as a system has been designed so that when we deploy in this topology in 3 different data centers, our replication factor for data was 3. That is, one entire copy of data was available in each of the data centers. And as and when we do reads and writes, we ensure that there is strong consistency and rebalancing and resharding of data at every single point to give you that high availability characteristics. So when the Texas power outage happened, all the traffic which was connected to Texas automatically got rebalanced to US East and US West. So from the RPO, RTO standpoints, the RPO for us is 0. So we have designed Yugabyte to guarantee that mission critical characteristics that we talked about earlier in the conversation today. Yugabyte has been designed in this topology to give you 0 RPO, because as soon as the entire copy of data here goes down, we have a safe copy of data kept either in US East or US West, and we can go tap into that. So RPO is 0, but the time it takes for us to rebalance the connections that were established in Texas and reconnect them in US East and US West is less than 10 seconds. And when I say less than 10 seconds, it depends on that customer's infrastructure, their load balancer configurations and things like that. But net, it takes us 3 seconds to reestablish the leaders of the shards that are basically lost in Texas in this case. And then rest of the time is basically to take care of reestablishing the connections and things like that. But at least in this case, we have seen that it came back up in less than 10 seconds without any issues. And for the next 4 days, we continued to operate the system without any issues. And after the power was back up, that means after this Texas set of nodes were back online, Yugabyte takes care of bootstrapping them with the right copy of data and automatically starts taking connection that belong to Texas directly. So this itself has a huge implication and huge benefit for this customer in terms of automated resilience guarantees, and more importantly, no human intervention required to reshard the data and rebalance the data. And that's a huge DevOps gains for the customer right there.
Yeah, and I love that story. I grew up in Texas, but missed that generational storm, but definitely saw some crazy pictures from friends in Houston and Austin as that was happening. So, I mean, this has been great. I really appreciate all these insights as we talk through system of record, use this product catalog as a great example here. Before we wrap up our inaugural episode here, any closing thoughts you want to share, any wrap up around this story you want to just leave our audience with?
Yep, absolutely. So I think just summarize the entire story, right? I just wanted to put one slide here. For this use case, again, we do several use cases with this customers, and in the coming sessions, you folks will get to hear some of this again, the different use cases. But for this use case, this was a mission critical global product catalog. And as you can imagine, it's very expensive to maintain a manually sharded application or mainframe style architecture for such an use case. So we were able to go and help them actually design a mission critical application with a stretch cluster that we had just discussed, and ensuring that their end customers have a seamless experience buying their products, scaling up and scaling down for Thanksgiving and Black Fridays. And more importantly, we help them eliminate the lost revenue. That is, prior to Yugabyte, they had a system in place where they had actually served wrong copy of data because of an eventual consistent nature of a product called Apache Cassandra, which itself leads to downstream issues. That is, you will end up selling a product which does not exist in your inventory because of eventual consistent copy of data that Cassandra served. So those issues are completely gone with Yugabyte. As we look through Yugabyte and the strong consistency guarantees, we actually help our customers recover their lost revenue. And typically, we would scale this cluster 3-4x times for Thanksgiving, meet their end requirement for Black Fridays and Cyber Mondays, and then scale down the cluster seamlessly. And this itself happens with minimal human intervention at any given point in time. So my key takeaway here would be you can apply these strategies to your own use cases, whether you're in finance, retail, healthcare, or any other industries. Even the IoT industry can leverage some of these best practices as well.
That's great, Amey. And I know we could actually keep going on this story as there's more to systems of record, as we were talking about beforehand, but we're going to have to save that for another episode. So stay tuned. I'll be reaching out to you to rope you into doing this again in the near future, if that's okay.
Yes, absolutely, Michael. Thanks again.
Awesome. Thanks, Amey. And to our audience, thank you again for joining us on our first episode of our new Architecting Data Strategies with YugabyteDB series. We've got a full slate of topics to cover to help you understand how YugabyteDB is helping in these real-world use cases. So stay tuned, come back, We look forward to seeing you all and talking to you all soon again. Thank you.